Hello, in this video, we're going to examine this live, looking at this composite figure here. Composite in that it's made up of several known shapes. So there's two basic strategies. One is to partition it into smaller shapes and add those together. And so there's several different ways you can do this. One way that you can do this is to cut this triangle here off to the left and then separate the other L-shaped piece into two rectangles. You could either separate it as a rectangle like that, or you could cut it across that way and make a rectangle so that you have three separate pieces. There's other ways that it can be done, but what you want to do is find something that makes sense for you. I'll give you some examples. So you could, for example, whoa, I jumped the screen there. Let me move back. You could draw a line or line segment from there to there and from there to there, and realize that you can make two triangles with a rectangle on top. Now, that might cause you problems. It might not cause you problems. That might be, maybe the easiest way for you to solve it. Actually, it's not a bad way to do it. What I did in the module page is look at one way that you can do it. But however you decide to cut this up, okay, is the way that you will be taking those three areas and adding them together. The other major way you can do that is to think about more area than what we have shaded. And so I did that by kind of outlining the figure with the rectangle. And it doesn't have to be a rectangle, but if you think about the rectangle that would go all the way around the shape or capture the whole thing, that would be 15 by 10 inches or 150 square inches in that entire outside rectangle. Then if we took away this space here, this white space there, we would be left with the question, which is, what is the shaded region there? Those are the two main methods, and I want you to explore those as you look at the challenges this week. I also want to mention on GeoGebra that you can find area as well. Haven't done that yet on any of my videos, but if you were to design or to draw a polygon using GeoGebra, let me just make an example here. Let's see. Let's make it fairly interesting. There we go. That's a fairly interesting polygon. One thing we've already done many times before is to find the lengths of the sides. Okay, you can click on any one of these side lengths, go to the settings, and you can have it show you the value of that. So we'd see the value of that as 2. Very, very useful if you were to want to know what the perimeter of this was, right? You can just keep going around this figure. That side is 2.2, that side is 3.8, and you could continue having GeoGebra to show you the outside lengths. But if you don't click on the segment, if you click in the middle of the figure, all right, then GeoGebra knows that you're talking about the polygon in general. And now when you go to the settings and you show the label, it's going to show you that inside piece, which is the area. So there's no units here, but what's going on is the outside length has lengths of 2, of 3.8, of whatever that length is, and those other links that I didn't get. These are all units, okay, 2 units. But the inside, when I click, this is my square units. So the area inside this figure is 26.7 square units, and you could use GeoGebra to make scale drawings and to find areas. Pretty cool indeed.